because I'll upload it as two different parts. Right now, what we want is that what we are trying to study again is leveling up our game altogether. That is right. That is basically the PyTorch 2.0. Now, a lot amount of discussion that is supposed to happen in this section. PyTorch 2.0, why not 1.0? Will come to that also. But first, it is important to understand what is PyTorch, what does it do, and why PyTorch, why not others? If what are the other options available as of now, and when should we use them? So all of those different things we'll be discussing in this section. Now, PyTorch 2.0 as of now is the most widely used library for building AI. Initially devised by Facebook, basically, or Meta now. They devised this library basically from C++ to Python and everything, right? Initially, the Torch library was present earlier, but then they started developing, and now Meta is actually actively maintaining it. And then behind all of the successful models that you see from OpenAI to Meta, Llama models to Anthropic models, this is the library that is responsible for everything. This is the library that is responsible for all of the research that is happening right now, right? So, and there is a reason why there is a reason why uh, this library is there. Now, for that, we will also have to understand that what currently exists in the current landscape. I mean, what is the current landscape of AI? What PyTorch 2.0 is able to build, and where it has, all of this, whatever I did teach you till now, kind of this was a prerequisite. In many of the online sessions you go, I mean, this is not even a point of discussion also. But yes, I mean, this is the very basic bare bones that is required. Now, obviously, whatever the programming till now you have seen, I mean, almost all of us, we come from the software background. We have seen applications working on. Most of these applications were used to work on CPU, but this time, why PyTorch? I mean, because PyTorch is first and foremost thing. PyTorch is a library that helps us run our program easily on GPU, right? This is the first point. So for GPUs, basically, yes, I mean, there is just small difference of few parts. I mean, not a very huge difference. They have made a very easy library using which we can basically directly run our programs on GPU. I mean, for us, it is just a flag, ideally, that GPU is equal to true. That's it, and it will start running on GPU. I mean, nothing more for us. I mean, as a user, because they have taken care of all the complexity down the line. Earlier, I mean, before 2015-16, PyTorch was even very popular. Uh, or even before that, I mean, AI is not something, or GPUs are not something that has popped up new. I mean, GPUs were right from the gaming industry and everything. So earlier, all of this used to happen using CUDA language. I mean, a language by NVIDIA. That is, they created a language just for GPUs. And usually, even there are some companies that even work on that level right now also. I mean, very few in India. Mostly those companies are those companies like they work on the driver level, or they're directly creating something uh, very high speed AI they are creating either, right? So these kind of companies are still working on the GPU level. Now, what is next? That obviously, when we talk about this thing, that all of the application space that we see from you know image applications, that is self-driving cars, self-driving cars to text applications, text summarization, ChatGPT, not just simple text generation, but also earlier to that, there were applications for text classification, and your sentiment classification was there. We used to call that natural language processing. We still call it NLP, right? All of that still, PyTorch holds a very strong. Uh, I mean, all of those algorithms are very heavily funded by PyTorch. In current, also it comes into current landscape. Then comes the level two. What is that level two? There came in a company called as Hugging Face. Right now, Hugging Face is a company that is very active with its model uh, library. Basically, they release open source models. A lot of open source models they have released, and a lot of these companies like Llama, that is Meta Llama, and Deep Seek, they publish their models on Hugging Face ecosystem. And they publish on Hugging Face, and if you go to ever Hugging Face, you see them. You know, they have wonderful. Even if you go ahead and see Hugging Face model ranking, LLM leaderboard. So they maintain a wonderful leaderboard that which free and open source model is basically you know performing the best. And these are some of the tests that that LLMs are judged on. You know, now they have also added CO2 cost, at how much is the GPU footprint or the carbon footprint that it is leaving. MMLU is again like massive multitasking language understanding. Then these are the data sets. Now there can be a case that this model can be performing better on this data set, but not very better on a generic data set. So there is a very huge chance because these models are specifically trained for all of these things, right? And if you see, these are very, some of them, this Quen, it was released by Quen. This is official Quen release 47. And this is some guy who released one model that outperforms Quen. Obviously, his model is also better than that, right? But does it means that it performs on everything? No, it doesn't mean it performs on everything. Basically, yes, these simple set of models, it performs better on these simple set of models. Yeah, we'll talk about it more. I mean, this is something we have to uh, basically. So all of this basically, yeah, Hugging Face again is a library, a wrapper written on top of PyTorch. Right, this is again one wrapper that is written on top of PyTorch. Then what goes after this? Obviously LLMs come in, right? Fine tuning of LLMs come in, right? A lot about LLMs, like scaling the LLMs, deploying LLMs, fine tuning them using various methods like Lora, QLora. Then on top of that, there are application frameworks now built on top of everything, like LangChain, LlamaIndex, for like searching applications, mostly what we call as retrieval augmented generation. This is basically LLMs, using LLM with search over huge corpus of application, right? Like a simple example can be a repository search. That is, you have thousands and 10 thousands of document, and AI is sitting on top of that, and then it is able to search very accurately from those documents and come up with an answer, or combine multiple documents all together and come up with an answer. A very you know so as of now 70 to 80% of the industry is using this RAG. So if you see around the jobs, it is around RAG, LangChain, LlamaIndex. This is the area wherein a lot of jobs are present. I mean, RAG, LangChain, and LlamaIndex. You'll see a lot of applications just around this one. Then on top of that, there are now agents, right? We have agents on top of this. So what do these agents do? Obviously, agents are like, we can consider them as individual task solvers, these individual task solvers, such as there is one agent that is specifically designed for searching the internet, and there is one agent that is specifically designed for, let's say, interacting with your system. I mean, just like I am interacting with my system. There can be one agent that is specifically for, let's say, doing the bookings, right? So specialized agents, I mean, they are meant for solving those special tasks only, and then all of those agents can come together at one place, and they can start working all together. And when all of these agents are basically working all together, then we call them swarms, or we can call them swarms. So basically we can have like multiple agents, this can be multiple agents, agent 1 and agent 2, all of these working together, agent 3, and all of them reporting to one common, you know like uh, maybe a one common manager kind of thing, just like humans do. One common manager, they can be reporting to all of to one common manager, and this one common manager will be like checking if the result by this manager, by this agent, is correct or not, and if it is not correct, it will reassign some work to it, right? So this kind of setup is there. I mean, people are trying to solve this setup, but is this setup really efficient? Not as of now. I mean, yes, we are able to do in certain cases, but I mean, this is not a very efficient setup as of now. Then on top of that, these specific agents can also interact with each other, right? They can also interact with each other, right? And they have developed a specific communication protocol, what is called as MCP nowadays, right? Earlier it used to happen via like APIs and everything, or text message or XML, but now, I mean, they have developed a specific protocol, MCP, for that. So all of these agents can communicate with each other, with the manager, and so on. I mean, now these are just different terminologies, but it is not that it is completely different. So this is the complete application layer. You see, this is the complete application layer that is present in this thing. Now, and we will be covering all of these things. MCP is there. MCP can query from your database. It can basically interact with web search. It can execute code. It can create small codes on the runtime and execute them. But yes, obviously, they all suffer with efficiency issues. They all suffer with efficiency issues. And a lot of times, what I also feel nowadays is that we have lost one art, and that art is the art of problem solving that used to happen earlier. I mean, down few lines earlier, what used to happen if there is any problem, or let's say, if there is any problem, do we really need some of these so complex systems to solve it? Do we really need so complex systems, right? If you have any problem, if you are having any problem, so do you really always need, you need an LLM? On top of that, you need agents, right? On top of that, what you need is MCP server, right? And then MCP server, on top of that, you need something else, right? A big fat architecture, and really solving something that earlier maybe a small AI model, or a small model plus a small application layer could have been able to solve. So yeah, I mean, this art is getting lost as of now. This art is getting lost. The reason being, the reason is very simple. People don't want to study. People lack basics, and what is happening? Clouds want you to become dumb. Yes. So all of these things, clouds are coming with all of these things. The idea is that basically, if you are, just imagine, if you are querying the LLM model one by one, when you're querying it by hand, let's say or your model is querying one query, it receives one response. At max, how many times you are going to query that model? Let's say, uh, if even if you are very busy, if you have written the application in a very efficient manner, you will maximum hit that server, I mean, 2000 times. This is considering that you have some fine, decent traffic coming in. Or let's say you have high traffic coming, it will be 20,000, right? But just imagine what these cloud providers want you to do is that they want that you have an AI model and you have an LLM and then you have agents, and you know these agents are regularly hitting your cloud AI model, and they're regularly hitting, they're failing, they're again hitting, they're failing, again hitting, they're failing, and then they're able to solve something out of it. And at the end of the day, you end up that you have hit, in one day itself, you end up hitting 10,000 calls to your AI in one day itself, right? Sorry, in yeah, one day itself. Now, in other case, I mean, if you would had written the problem solving properly, you would had done problem solving properly, your monthly hit would had been 20,000, or maybe let's say 30,000, max 40,000, right? This is very heavy usage, ideally, what I'm telling you. But yes, so what is happening? People don't want to train anything. They just want that, yeah, we'll pay that. We don't want to spend anything. We just want to pay here, right? And we'll get this LLM subscription, and we will maybe add another set of models here, agents here, and then we are good to go. We'll add that we are AI enabled, and we will increase the cost also of the softwares, right? We are AI enabled, will increase the cost, right? And do all sort of things. I'll tell you a fun part. Till now, people, there is no single methodology that is in concrete manner that tells you how to test properly agents, MCP, and LLMs. There is no single methodology that is properly established. Obviously, if you go and search, you will find out that yes, there are certain ways to test them out, but there is no standard way to test this whole system proper. So basically, what happens is, it's all working on the faith, right? That okay, you get your LLMs, you attach your agents, and then you attach your MCPs, or if you want to use MCPs or not, but you attach your LLMs and everything. You attach a lot of few agents, and they keep on running, and they solve the problem. At the end, when you are not able to debug it, you end up maybe purchasing more costlier LLMs. You sell that, okay, we'll spend more time and we can increase the size of agents, and then they will uh, essentially help us in increasing our accuracy. So obviously here, who is the single company that is actually gaining a lot of things? It's the cloud. So clouds are obviously against the idea that you should be building anything. Also, what I'm not saying is that should you be building every time everything of your, no, you should not be doing that. But yes, what I'm trying to tell is that breaking down the problem is very important, and hence people come up saying that the AI is very costly, the AI application is very costly. Now, I, in my previous organization, when this whole thing was down the line that AI is so costly, AI is this and that, I gave them a solution that was $10,000 a month also, and I scaled down the same solution to $400 a month, the same solution, right? The only point being that you need to decide that what is your target audience you need to cater. Do you need to cater to small audience? Obviously, this $400 thing is going to do the job. Obviously, if you are ready, like you are already ready, you know that there are a lot of people who are going to hit my server and everything. Obviously, then you can go ahead for $4,000, $5,000, or $10,000 server, or whatever you wish to, right? So basically, it all depends on the application and on the problem, right? Now, going back to our discussion, that uh, let's have a look at first a small. We have been talking a lot about it. At least let's have a look and feel of our own personal small model, right? A generative model, what we call. I mean, We have talked enough of all of these things. Now coming back to one of the questions by Vikram, that what is small language model, what is large language model, right? So basically what happens is that, so how does it happens that we did learn about parameters. We did learn about what are parameters, right? We did learn about parameters, and we did learn about hyperparameters. This was small comparison that we did in our yesterday's class only. I can go back to that slide because that will help us in again reiterating over the same thing, right? What is model parameters and hyperparameters? So model parameters are very simple weights and biases, right? And hyperparameters, basically the learning rate, number of hidden layers, number of neurons per layer, what is the size of the data, number of rounds of training, what is the activation function you are using, max trial, let's say in AutoKeras it was max trial. All of these are hyperparameters. So when we talk about the size of the model, usually it is via the parameters, that is weights and biases. So when we call about, so if we see the DeepSeek is doing a comparison here, I guess, I do not know. They'll be providing anything. I'll go with an image. I'll go with this one. No, I do not know where this image went in. Right, here it is. So if you see here in this image, this GPT-2, it was dead small. It was 9.5 billion only. Google BERT earlier to that was even small. I mean, these are the small models. And what about these big ones? Facebook, BlenderBot, they have released 180 billion model, right? Then this DeepMind, they have released 1.5 trillion models. Anthropic, 400 billion models. Google Palm was already very big. I mean, this is not a new one. It was released already, I guess. It was 180 billion model. GPT-3, although nobody knows what is the size of GPT-3 model, we are just guessing out of here. It is 500 billion model, right? And I'm worried. I mean, why 500 billion and 400 billion is right? Anyways, this circle 400 billion circle is larger as compared to 500 billion, but let it right. So these are the sizes. Now, what are small language models? Small language models are small SLMs. SLMs are smaller models. I mean, 1 billion model or half billion model, half billion parameter model, or even smaller than that, 100 million parameter model, right? Why are they even called language models, right? That is question number 2 that we will see when we solve one of our Google collaboratories. By the way, any questions on this exciting introduction?
Yeah, Anand. So
Yeah,
again, just a little confused about the terminology here. So when you say 3 billion parameter model or Google, for example, being 700 billion parameters. So
right.
those parameters are the normal parameters or the hyper parameters?
Weights and biases.
Weights.
Model will only be shared by only be measured by parameter. Hyperparameter is for optimization. So we trained our model using hyperparameters.
Oh, it's more like how we say meta parameters kind of. Okay,
Right,
metadata. Okay.
right,
So if you're saying weights and biases,
right.
so is it that the total number of weights and biases is what
Tentatively, yes.
tentatively
Yes.
that is what is this 2 billion,
Correct.
3 billion,
Yes.
9 billion.
Yes. 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 Yes.
So
And
it is not, sorry, yeah.
yeah, and hence, when we say that, we were just seeing the visualization of 7, 8 neurons yesterday, right?
Hmm.
A 3 layers model, we were seeing that visualization.
Yeah,
Remember
yeah,
that?
yeah.
And now imagine these 400 billions lighting up and glowing down, glowing up, glowing down. I mean, here it becomes impossible to track them,
True, true,
right?
true. So again, just going further on that point only, the weights and biases are within each perceptron, right? They are inside a perceptron. Like,
Not inside. They're along with the perceptron. But yes, I mean, uh, quite fair enough. They are inside the perceptron. That is also not a wrong assumption to assume. Yes, in every neuron, basically, this again, we coming to the same one, I1, let's say an I2, right? Input and the equation. So W1, W2, the weights and the biases. So I1 into W1 plus I2 into W2 plus the bias. This is the equation of a neuron plus on or off, because I'm
activation
again
step function.
activation function, step function, the
Correct,
again activation.
correct.
This is one neuron, right? This is one. Now, it is not that it can have just two weights. It can have multiple weights, right?
But
It can have,
one particular neuron will have a predefined number of weights, right? One particular neuron.
yes, yes, yes.
That will not change, right, in the model.
We can change that. We can change that,
Okay, we can
right?
change that.
We can change, because see, I mean, ultimately at the end of the day, ideally, the number of inputs you are keeping here, you can increase this equation, right? This plus part is one part. You can go ahead and increase this equation, right? I1, W1, I2, W2. You can go ahead and increase it,
So that is
right?
in our control, as in, is it? We can
Uh,
control.
we can control that, but ideally people don't do it. We usually, when we go to the PyTorch level, we will directly define at the layer levels. We will directly define that we need layers. How many layers we need? We need 2 layers, 3 layers. In one layer, we need how many perceptrons? This is
Okay,
what we usually define.
okay.
But yes, if you go ahead and you can basically go ahead and configure this also. I mean, if you make further, like if you go down further. But yes, these weights and biases are the parameters using which a model is measured.
So technically, a perceptron or a neuron is nothing but this equation only, right? And
Yes,
along with the activation function.
yes, yes. This is what is a neuron. Yes.
Oh, okay. So now coming to my main doubt is that the size of the model, whether you say 1 billion model or 100 billion model, is that the sum total of the how many W1, W2 you have across all the neurons, or is it just a total of each neuron?
All the neurons. All the neurons.
So I1 into W1 plus I2 into W2 plus B will be considered as one neuron or two neurons?
These are how many weights? These are two, three weights,
Yeah,
right? These are three weights,
ah, correct. Two weights and one bias. Yeah, three total.
right? Correct. So similarly, we will be now you can assume that if they are saying that 100 billion parameter of model, so it will have around 60 billion neurons or something, or 50 billion neurons. It will have somewhere around that.
Okay, got it. Understood.
So, Anand, one question, how are these layers decided? Like, we need X number of layers. How is that determined?
Ideally, we go with the hit and trial method. I mean, not exactly hit and trial, but yeah, I mean, most of the developers they go with the hit and trial. But yes, I mean, you can go ahead as you go ahead and train your models. I mean, uh, because now what happens is, okay, we know that, okay, this is the problem you have to solve. Then obviously, first you can start with 5 layers. Then if
Mhm.
you're not, it is not performing well, then we will make some changes, right?
Okay.
Now we make changes to hyperparameters, right?
Mhm.
We make changes to hyperparameters and then we try to increase the accuracy. This is what AutoML was trying to do,
Okay.
right? AutoML was taking care of all of these hit and trial things automatically.
Mm.
But now we jump into the core PyTorch. That is, we will basically see here that what we need to do, anything we need to add, anything we need to remove. So we'll be checking all of those things,
Okay.
right?
Okay.
Great. Any more doubts? Okay, good to go, I guess. So basically, what we'll try to do here is uh, just to make things more exciting. What I did was I tried.
Anand,
Yeah, yeah,
one quick, one simple point question. So if
yes,
someone, like let's say, tells me tomorrow that okay, we have come out with this new model, like let's say my company only, okay, where I work today, Konga,
right.
they come out with a new, let's say, a feature where they have a model which they can query across the entire repository. Okay, I'm giving you just a real example.
Correct.
Would it be a right question for me to ask them, let's say, can you tell me how big this model is in terms of the size? So is that the right question to ask them? Will they know
Yes.
that or no?
Ideally, they should know it, and they will know it. But what happens is, I mean, sometimes for coming up with this kind of solutions, there are series of models they have involved. It is not just one model. I mean, like the agent thing and all what we are talking about, So there are some series of 2 to 3 models in combination they involve, because with these kind of use cases, the accuracy is pretty low. So yes, I mean that's a completely valid question. You can even ask them how did you train it if they want to reveal it at all. I mean, if it is internal meeting, you can ask them that how did you train it, or what kind of model are you using? Are you using agents in it, right? So all of these are valid questions. Did you train it yourself or did you fine tune it? I mean, training is something that we did right now. Fine tuning is basically you take another model and you just do some delta training on top of that, right? So most of the time it is fine tuning. I mean, until unless the company has a lot of budget and the company is very dead serious about what they want to build about. I mean, uh, they just want to blow the market altogether. When they have this kind of seriousness, they usually invest a lot in training the model from scratch and all of those things.
But will fine tuning give similar results or will the results not be as good as if it was like training, proper training?
Fine tuning will add small amount of knowledge only to the existing model. Pre-training is teaching it from zero, or training is teaching it from zero. Like we did see in the first demo,
Yeah,
that everything was zero,
correct. I remember
right?
that. Yeah.
Right.
One
And
plus two, the addition basically.
yeah, exactly. Everything was zero. But then it learned. Now in fine tuning, you are actually beginning from somewhere. Already the weights are trained. Now you're just adding some small data on top of it.
That means if we are using any LLM, if like
Right.
I'm sure like my company is also using an LLM, although I don't know for sure, but I'm just
Yes.
assuming.
Right.
That means they already have a LLMs already pre-trained, right? They have the trained weights and biases. So it means that most likely companies like us are probably just doing fine tuning on top of the LLM. Is that right?
Yes. Yes. 98 to 99% of the companies are just fine tuning. Some of them are not even fine tuning because even that is a complex job,
Okay. Just
right?
using LLM as is.
You use LLM, you use a mid layer in between, right? And that mid layer will just take care of some of the answers and everything and rules, and you expose it and finished. And you call it that we have trained our model, right, on a custom data.
Hmm.
And this number is as big as 85 to 90%.
Across the world. Huh?
Exactly. They're not even doing anything. They're just using ChatGPT. They will build a small layer in between, and that layer is also not that complex layer. They'll build a small layer in between, and then they are done.
Okay.
Yes.
So if I want a really good, well-trained, very specific to my use case, whatever my use case may be, let's say risk extraction from a contract. Okay.
Right. Right.
Ideal solution, although let's keep the cost aspect aside, ideal
Correct.
solution would be to train create and train a fresh brand new LLM as
No. Because training a fresh LLM from scratch, it will burn out a lot of things. So ideally, what you do is you take one model, you find, even if you do the proper fine tuning, right? We will discuss what are the different ways of fine tuning. Even if you do proper fine tuning, even then models are able to perform very well on specific use cases,
okay.
right? They will surpass the general accuracy very easily, and even they will beat 70 to 80% of your competitors very
Okay.
easy.
Okay.
Now, assuming that, obviously, point being that so even in that, Vikram, so for all of you, since I guess all of you have gathered here that all of you want to build something out of AI in future, data is the key here. And hence I was telling that there are startups emerging just on data management. Once your data is in place, you know, then you can choose any LLM and you can just start training and like experimenting that how this data is performing. Once your data is in place, everything is sorted out.
Okay. And we can use any LLM basically by using that
Right.
data, but that we have gathered. We kind of fine tune the any
Correct.
existing, whether it's ChatGPT or Llama,
Yes.
whatever.
If there is any you can fine tune chat gpt, right? There are few other llms, like you can I'll refer to few more websites that allow fine tuning on premises only, right?
Okay.
And then we will see some applications which you can download on your system or on your server, and then you can fine tune that also,
Okay.
right?
Okay. Got it. Got it. Thanks, Anand. Very insightful.
Sure. All right, team. So next, basically what we want to do is, right, we want to feel our first magic, right? So this is what I want to do, that we will be running a small uh, language open source model, right? Here I prepared a notebook for you which you can go ahead and learn. Now basically, obviously it has few other things. I'm using an existing model, I'm not training anything. I'm using an existing model, and this existing model is GPT-2 model, not the GPT-3 model. This is the open source model. The very beginning models, when the GPT broke out, this is that model, and then they open source that model after they released GPT-3, right? You can use Llama or any also. I just ran it because I wanted to run it on CPU and everything, right? This is a pure CPU model running on a very free collab version and everything, right? And here I go. I will first, this is my hidden cell where I have written few helper functions. Now this is basically what I'm trying to do. As of now, I don't want you to expose to all of these things because I don't want to push you into unnecessary complexity. I've made those helper functions. You can just go ahead and run this. And it will take some amount of time. Everything that you require to run is already present on Colab. So basically, hence Colab is so good. Most of the times, the standard libraries you will mostly find in Colab. You don't have to add a lot of extra installations and everything. Okay, this is done. And this is my model name, right? And I will initialize my model. I'm loading my model. This is not a full model I'm loading. I should tell you that also. The full model is quite big. So what I have done is I have sliced down the model. Slice downing the model is as simple as that. Since model, when we load the model, it is basically a big matrix. I can slash down by using some operations on the matrices, right? And it says your AI masterpiece is ready. Let's get ready. And it has, this one is very like lightweight model, very lightweight. It just occupied 1.7 GB of my RAM, right? And done, I guess. So I was just playing around with few prompts. This was one of the prompts. So we can say that, can you write a small poem for me, right? Now, basically what I have done is maximum length is something we'll have to take care. As of now, I have kept the maximum length as 200. And then this is temperature. Now, temperature is something whenever you are even playing normally with any model around Anthropic or ChatGPT. Anthropic, I guess, is not giving you in the chat version, but if you go in the API, you will find temperature, that how much is the temperature. Temperature in simple terms, later on we will see temperature has to do something with the activation function actually. But as of now, I will not confuse you. In some simple terms, it varies from 0.1 to 0.9 usually, or actually 1.0 it goes 1.0, right? And 0.1 means when you want accurate and same kind of answers, right? And you increase it if you want more variability in answers. Usually how these LLMs promote it, they say this is creativity knob. There's no creativity knob, right? Because it is just coming up with different randomization, right? So basically it is they are coming up with randomization, right? Basically it has to do with the activation function in the last output layer. We will cover it when we'll go ahead, basically because I'll have to explain you that specific activation function only, but we'll see. Here I see this and then I say that let me generate it. Okay, and it will take some amount of time, not infinite amount of time. And see, it has come up. I am master poem teacher and I love it and I think it's wonderful poem. Is there anything you can do to improve it? I don't know, I'm just trying to do what I can make it for you better. And it did not, I mean, this was not something very good. We can write we can ask some question to it. I mean, just like what is difference between India and Pakistan, let's say. Right. The word Indian means place. The first two, Khan, which means a place, and place of mind related to words Indi, Indu. Indi is the first word, Indiana. The second, this is interesting question. I'm big fan of it. Has gone to some other place, although physical. Okay, this is again something not in context, but yes, I mean it is always not like we can say that. Can you tell me about the Delhi? About Delhi, let's say. Can you tell me about Delhi?
Anand, now
Yeah,
we know why people, when they make resumes with ChatGPT,
yeah,
problem.
right, right, right. These are kind of. Can you tell about Delhi? I was told the same name was changed to Jiljina, and it was the last name, sister. Bibliography. I'm sure that you have read all my reviews and so again so let me actually go for 0.1. I'll go for 0.1 this time, right? And I'll ask that what is quantum physics? Uh, let's say I'll ask first a simple one. What is quantum physics? Right. So now it has become basically what it started focusing more, and basically this question I know it is present in the training corpus of every basically training that has been done. Quantum physics is a theory of law of nature. It is a theory that we know about the universe. Quantum physics has been around for a long time. The first quantum theory was so and so, right? So obviously this question I know because I have seen some like training data present. So let's say what is entanglement If you say what is entanglement, this is again a concept of quantum physics. So this is very small model, and then I did slice it even to load. So basically, even when we slice it, it will lose some of its intelligence. The answer is, and is a very important part of the, it is important thing in the word. The game is about players' ability to move, map, and other players. Again, some rubbish. It came up with something rubbish. So basically, on something that it has been trained, it is uh,
So
what
Anand, I have a same question actually. What you said, right? You slice it, not use the complete model. So where exactly we can find that? How
you
we
can
can decide? Yeah.
Hugging Face. You can find a lot of models on Hugging Face. Go to Hugging Face
Mhm.
and you say here, use libraries, data sets. You'll find the data sets. You'll find languages, and you'll find models here. You'll find all of the models, right? And let's say even if you want to, what kind of model do you want? You want what? Text to text, text classification, natural language processing, question and these all are called question answering model, Llama and everything. These language models, right? So here are some of the models like meta models. Even if you want to find out the meta models, trending most downloaded models. So DeepSet is one of the most downloaded models. Why DeepSet is not very discussed but model, but yes, I mean it is used for RAG, that is Retrieval Augmented Generation, searching use case. It is a very favorite model. Google Bird, and DeepSet again, Distilbert.
So in your example, Anand, the GPT-2, right, the model,
Right.
but where exactly you slice it? How I can know, okay, you slice it this model and use it in
Yeah,
your.
actually, so basically what we do is uh, either there are a few ways to do it. I can directly go to quantized model. I used to publish my own model also. I mean back, this is my model. This has been published by me. This is my model. Now this model is a 10 GB model, right? But it has been it is a sharded model. It is a 8-bit model, right? Basically what I have done already. I mean there are few ways to do it. It is not necessary when I'm reading the model, I can cut it down or I can slice it down. Maybe even when I'm saving the model, I can do that also, right?
Okay.
Even when, right, even when I save the model, I can do that also. So I saved 2 to 3 models. I have to change my name. Yeah, this is me, right? I have to change my name. Yeah, this is again one more 32-bit Llama model published by me on. This was again on open source legal data sets, and this is a very fast model, CT2 model. Basically, it runs on C++ model, right?
And is this the free or every prompt have some?
These two, which one? This model, what we are running right now?
No, no, whatever. For example, I wanted to consume your model, whatever you have published.
Yeah, my model is under Apache license 2.0.
Okay.
The licensing is, if you see now, this is Apache 2.0. But whenever you visit any model,
Mm-hmm.
usually they all are free, but many models do not. For example, I guess DeepSeek. DeepSeek is again Apache license. So we'll have to look for licensing.
Got it.
DeepSeek V2 Tiny. If we just have a now, it will be license DeepSeek. They have their custom license. So we'll have to go and look for the license that what it is saying.
Right.
If it is allowing us to use for commercial purpose, then we can use. See here, they have written use restrictions.
Hmm.
For military, I mean military cannot use it, right? So they did not write that you any organization cannot use it. So obviously organization can use it, right?
Right.
Because usually what happens then in audit or somewhere, if you are using any unlicensed model, then it can create a problem for us.
That's correct.
Right. So yeah, correct. Now going back to our model, okay. And with in quantum physics, I'll ask one more in quantum physics. The entanglement fundamental of quantum mechanics, it is the principle that determines properties of particles. The principle is called entangling. So the entangling principle or entangled particle is one of the fundamental of physics. Okay, this is why it is entangled. So it has given some relevant answers, but not completely irrelevant. If you have large number of electrons, you can have particles. And then as you go on increasing this max length size also, it will take more number of memory also. So hence, since we are on the free version, so we are limiting our memory usage and everything. Right. So with this, you now I'll share this script also with you. So we have our first, uh,
Uh,
yeah,
Anand, one doubt, you said like you have not downloaded the complete model on only part of it, right?
right.
So that like same model with different billions of parameters and means in different sizes it is available. So you need to say that you have downloaded the lower size one.
Yes, this is a very small size model. I mean, extremely small size model. Hence, we are able to load it, in so conservative memory and everything.
So the
So
the size in billions of parameters is what you refer to when you said you didn't download the complete model. Did you refer
yes,
to that?
exactly. This is the size in billions that we did not download the complete parameter. I mean, we actually what we do is, let's say, ideally what happens is, let's say, complete matrix of model is in 32-bit size. So we bring it down to 4-bit or 16-bit. So it automatically, we call it quantization. That process is called as quantization. So in quantization, what happens basically, we cut short the data. Now, when data is cut short, obviously the size of the model becomes smaller. It can load in lesser amount of RAM and everything. But then basically there is some loss of precision also. A loss of intelligence is also there. So all of those AWS free models or cheap models that we see, uh, those are quantized models. People do not know it. A lot of companies are using it without even realizing. They say that, what AI is, why this AI is so cheap, because AWS providing some APIs that are very cheap as of now. I mean, basically they want uh, you to use them and integrate in your application. But Anthropic model, when you purchase from Anthropic, it is costlier. When you purchase from AWS, it is very cheap. So basically, the reason being that they are giving a quantized version. Even the output will also be different. For simple use cases, it will be fine, but for complex cases, the output is going to be different.
The same DeepSeek is there ranging from 1 billion to 270 billion parameters.
Yes. The larger the model, the more intelligent it is going to be, obviously, right? Because more number of parameters, now it has to do more number of calculations, right?
Yeah.
Okay. All right. So with this, actually, it's time to start with our PyTorch thing. But yeah, obviously, we will not be spending, this being our first day, will not be spending too much amount of time. There is just one concept that I want to start on with PyTorch, because that is the concept, and like everyone got excited about quantization also. So basically, then you will have to understand this tensors also. because this is where slicing happens. So it is tensors that are responsible for all of the slicing. You know, tensors are nothing. In simple terms, tensors are again data types, right? They're again data types. I mean, they're nothing fancy. You know, I just have few visualizations also. If you see, this is a tensor visualization. So very simple that what is this 1, 2.51 minus 30? This we have been seeing till now. Again, what is the difference between tensor and array, right? This is again an array or a collection of elements or list, whatever you call it, right? So this is a tensor. Now, tensor is a specific data type that is provided by these libraries such as TensorFlow, or TensorFlow name is itself on tensor. They are on libraries like TensorFlow and PyTorch and few other libraries, right? Basically, tensors are those individual elements on which complex calculation can occur, and they can efficiently interact with GPUs, right? These tensors can efficiently interact with these GPUs. Optimized maths operations. Everything here is matrix multiplication, gates, that is the gates that you studied in your 10th standard, right? They're very efficiently doing the calculus inside it, right? You don't have to do all of these things. Memory efficient, they consume a lot less amount of memory. They're fast. Now, you saw that, I mean, it took me huge amount of time to do that model training, right? 1 hour, 2 hour for one simple model. But when I go for huge models like training any uh, language models or anything, right, then obviously I need very efficient data structures. Tensor is that, and tensor is nothing fancy. Tensor is simple. This is 1D tensor, right? I can go ahead and write anything 6 comma 7, simple as that. This is 1D tensor. And tensor is created, this is the code for tensor. Tensor is created using import torch. Import torch is the library using which we will import our PyTorch, and then using import PyTorch we'll go for torch.tensor, creating 1D tensor, right? And what is the 2D tensor? 2D tensor, simply it will have two rows and columns like Excel, right? It will have rows and columns, 3 by 2, 3 by 3, right? 1D, 2D. This is what we saw when we were flattening our images. You know, we got the data initially in 1D, then we converted into 2D, basically 8 comma 8. And how do we make 2D tensors? The same way, torch.tensor. Tensor 2D is equal to torch.tensor. It is the same way we are making our 2D tensors, right? Now we will be doing everything on tensors, everything on tensor. Now tensor is not something very complex, but yes, we can easily move this tensor to GPU whenever we wish. So we can do our calculations in GPUs and everything, and whenever we wish, we can do our calculations in CPU, depending on our whatever requirement we have. This is 1D and 2D tensor, and then we also have is 3D tensor. What is a 3D tensor? Now 3D tensor as of now is a stack of 2D tensors. That is, what do you mean by this? What I mean by here is that stack of 2D tensors. Let's say this is one slice. This is one slice of 2D data, right? It has some data like this, and you keep on stacking this slice. You add one more slice here, right? You add one more slice here. So this is your one, and then there is one more. sitting behind it, right? And there is one more sitting behind it, right? So this is 3D. This is slice 1. This is slice 1. This is slice 2. And this is slice 3. When we add up too many 2D stacking one behind 2D frames, stacking one behind another, we form a 3D data, right? This is what it is basically. We can see it in form of a cube or something. Usually, most of the times we will either use 2D or 3D tensors mostly, right? 2D or 3D tensors. Now, if you see, this is 4 cross 1 by 1. Now, just try to visualize this. This is slice, single slice, and single slice is having some depth. This is one slice, one data, and this is having some depth, right? 4 comma 1, and then it is having a depth of 4. The 4. Now, if I go for 2 comma 2 comma 2, one slice length is 2 comma 2. This will be, I guess, I mean, I missed by mistake. I have taken this cube in same color. I should have done it in different colors. So this is the size of one cube, and the other data types are stacked behind it. All of the other depth is stacked behind it. The shape is 2 by 2 comma 2. 2 by 2 is the length of the size, and 2 is the depth of the size, right? And same goes for 3 comma 1, 4 comma 1, 4 cross 1, right? Whatever we want to have it, right? We can see those things. So, and how do we prepare a 3D tensor? Now, this can come up with a trick. Although this might seem like, it is what we are seeing here is 1 comma 2 comma 3. 2 comma 3 is the slice data. 2 comma 3, and it is having depth of 1. That means it is having one depth only. Now here you see it is 2 comma 2, but it is having 3 slices. And where are those 3 slices? Slice 1, slice 2, and slice 3, right? That is, these 3 slices are stacked together, right? So this forms a 3D tensor or 3D array or whatever you wish to call. Can there be four dimension thing also? Like till date, we are not able to imagine what is 4 dimension, right? But mathematically, what we see, what is 4 dimension? I'll explain you that what is 4 dimension. Stacking up of 3D arrays is 4 dimension. When we stack a lot of 3D arrays, although I am not discussing that 4D array this time, I will show a visualization maybe next time. But just for the reference, that what is 4D array usually? Let's say I have this cube here, right? This is cube 1. This is cube 1. This is 3D array. And these 3D arrays, you start arranging them in this direction in height, as well as in this direction, that is in the backward direction, and in that is this becomes our y, x, and let's say the z direction. So when you start stacking, I have a visualization for this. I know by hand it becomes difficult, but yes. So ideally, stacking 2D becomes 3D, right? Then stacking 3D together and actually stacking 1D becomes 2D. When we stack together 1D, it becomes 2D. When we stack together 2D, it becomes, and when we stack 3D together, it becomes 4D. Now, 4D, nobody has seen how does it looks, right? But yes, I mean, we have a small visualization that this is how it should look like if at all 4D exists, because our word is 3D. And this is the beauty of mathematics, that even something that does not exist, or even if it exists, no one has seen it, right? a very interesting theory comes up that fourth dimension is time, and someday when we will discover the fourth dimension, maybe we can move across the time freely. But yeah, I guess that time is never going to come. But yeah, I mean, in next section we'll see what is 4D array. Now, I'm not making it very complex as of now from starting itself, right? There are things that we need to discuss in PyTorch. Now, since we are already 4:12, so what I'll do is I'll stop this session as of now here, and I'll keep 1 hour for all of the practicals and issue discussions. So what we are going to do is we'll pull up our practical files, and I will share this one also with you, your AI model. Start running this AI model. I mean, there is nothing basically to be worried about it. This is simple, plain. You don't even need to install anything, but you can go ahead and start running it. Now, what I can do is basically I can give you few more model names that you can start experimenting. You can start running, if at all you can run in your local, because you have to be careful about your uh, size and memory. Right. So let's go back to our practical sessions now. Any doubts anyone is having?